Hello, good evening. Today is December 29th, 2020. I'm Bhavani Thuresingham from the University of Texas at Dallas, and I've been recording a series of video presentations since May of 2020. And these presentations are mainly the keynote addresses I've given over the last 9 months while working from home during COVID-19. And so just before I give a keynote, a few days before, I make a recorded video presentation, just in case there's a technology glitch while I'm giving the live presentation. So then I post the video presentations on YouTube. So what I have been doing this week, since December 26th, so 26th, 27th, 28th, and today 29th, I've been preparing video presentations of some of the keynote addresses, some major keynote addresses I've given over the years, as well as some other presentations, but it's mainly some of the past keynote addresses I've given, starting around 2006 until around 2016, 2017. And so these topics have included malware, reactively adaptive malware, and that's a distinguished lecture I gave. It's called the Polycarp Kush Lecture at the University of Texas at Dallas in May 2013. And I've given that lecture to the general public, like the public libraries and subcontractor associations in the DFW area. And so I taped that presentation on 26th, and 27th was a keynote address I gave on data mining for malware detection or data mining tools. It's based on a book titled Data Mining Tools for Malware Detection, a joint work with my students and colleagues, in particular, Professor Latifa Khan, and also his former PhD student and my former postdoc, Dr. Mehdi Massoud, who is now a professor at the University of United Arab Emirates in Abu Dhabi. So that was 27th. And then yesterday, 28th, so I continued, to give these presentations. And the topic for yesterday was on, sort of topics related to data and security, so big data. And one of the directions that I mentioned, so it was actually cloud-centric assured information sharing. So that was the topic for yesterday, secure cloud and information sharing securely in the cloud based on policies. So that's a keynote address. So again, backing up a bit, data mining for malware detection, a keynote address I've been giving from about 2000, as I said, 2006 to around 2011, 2012, right? So we write the book. And then I talk about cloud-based malware, cloud-based assured information sharing. And that's a keynote address that started around 2012-13 and continued until around 2016. And so I talked about 3 topics for the future. One topic was big data security and privacy. So that's something I'll be talking tomorrow, which is going to be December 30th. And so that's sort of a short video presentation I'll be making tomorrow, December 30th. Another topic, and so that was the big data security and privacy was just a couple of talks I gave to various agencies in Washington, because we hosted a big data security and privacy workshop sponsored by the National Science Foundation, and that was in 2014. 2014, it was in September, and then I gave a presentation of our findings to the agencies in Washington. It's the Interagency Working Group. And today's talk is going to be social, and so that I'll be talking tomorrow, okay, December 30th. Today's talk is going to be on, so today's talk is focusing on social media security and privacy. This is a talk, a keynote address, versions of this at least, I've given starting in 2012 until around 2016. And I still include parts of the presentation I'm going to give as part of a larger presentation on different topics, right? And that I've been giving the last couple of years. Okay, and then I'll be doing one more presentation this year because it's December 31st, which is on Thursday. And so I'll sort of do it earlier, earlier during the day because I don't want to wait till midnight and give the presentation. So that's going to be another topic. So I will, look at the various topics, so I call this sort of a historical presentation because it's sort of, I want to, compile these presentations mainly for history because what I find, see, I've worked in cybersecurity for 35 years. I started in 1985 fall at Honeywell, and then MITRE Corporation, and the National Science Foundation, and then University of Texas at Dallas. And I find, when I started working, there were probably around 100 to 200 people doing research in cybersecurity. And it was called computer security, database security. Okay, but today there are lots of people working in cybersecurity, but they don't they don't know what's happened before. A lot of the work that we did in the 1980s and 90s on multi-level secure database system, they really, an inference problem, they really don't seem to have any idea what has gone on in the past. And so I gave a historical talk on multi-level secure database system over the past 9 months. I believe it was in June. And so there's another historical talk I want to give on inference problem, but that probably I want to give it sometime next week. So I've got four lectures planned also next week. And then I will, get back into my regular schedule of, taping, video taping conference and some panel presentations before I give a keynote address. Okay, so it's a long presentation. I'm going to give 62 charts, but some I'm going to sort of skip through. So what I'm going to do now is share my screen. And then once I finish the presentation, I'll sort of come back and give some of my thoughts, some closing thoughts. Okay, so I'm going to share my screen. Great. So it is security and privacy for social networks, or you can call it social media security and privacy. And so I worked with two of my colleagues and together with several students, Dr. Murad Kantajalu and Dr. Latifa Khan. And so although I put today's date, it's again compiles a series of presentations, keynote addresses I've given over the years. So the acknowledgements, we thank the Air Force Office of Scientific Research for sponsoring this work. Okay, so, much of this work was carried out between 2006 and 2016. Actually, it's a little bit earlier, probably around 2015, but some work was carried out in 2016. And we acknowledge by name those who have contributed to the work under each section of this presentation. So it's multiple sections, right? You'll see in the next chart. And we have presented versions of this video talk in various keynote addresses at conferences. And I've included a sample. I believe my first talk was on assured cloud-based social networking. And that was I presented at the conference organized by the Chinese Academy of Sciences on social computing. It was in Beijing, China in November 2012. And then I gave a variation, analyzing and securing social networks. And some interesting points on this particular talk. I'll talk about it in the next chart. So two talks, it's almost very similar. So there are minor variations. A World Wide Web workshop on social networks. This was the ACM World Wide Web Conference. It was a workshop on social network security and privacy. It was in Rio de Janeiro, Brazil in May 2013. And that year I went to Brazil twice. And those were the only two times I went. One was Rio de Janeiro. The other one, the same talk, or at least a slight variation maybe, a keynote address, Society for Design and Process Science. It was in Campinas, Brazil. So that's near Sao Paulo. And it was in October 2013. So those two talks, sort of gave me the momentum to write a book on this topic, and I'll talk about it in the next chart. And then cloud-centric assured information sharing, social networking and big data. And so that was the IEEE ACM UCC conference. So it's information sharing, social networking and big data. I should put all of this in italics, right? So all of this is actually, let me just correct it because that was the title of my talk. Sorry about that, but okay. And then again, so that was in December 2014, part of the IEEE ACM UCC conference on cloud computing, big data, social networking and security. And then I was supposed to give a talk. So it was going to be a variation of these talks. And then there was analyzing and securing social media at SNAMS, the social networks, I think it's analytics, management and security, or modeling and security. So I gave the keynote address actually in Vienna, Austria, August 2016. It was part of the FI Cloud conference, but I was supposed to give it in 2015 in Rome, Italy. Okay, but unfortunately I couldn't go to Rome because if you listen to my presentation yesterday, I gave a keynote address at Noida in India near New Delhi, and that was August 19th through 22nd. And it was a very interesting story. It's kind of scary. So what happened was, okay, so then 22nd evening, I was supposed to go to London and then fly so I went to London to New Delhi, and then 22nd was supposed to fly to London. And somewhere, I remember in New Delhi airport, they will want itinerary printed. And some or other, I didn't know that, our receipt. So, because they wouldn't issue tickets. And so the person who dropped me, had just dropped me and gone away. So I was struggling to, log into a system, or nobody was helpful. They were not helpful at all. And so finally I found a machine, I logged in, and then I, got a printout. Oh, my password wasn't working for American Airlines because I got it American Airlines, British Airways for some reason, because I was also frantic because I didn't want to miss my flights. So then what happened was, okay, so then I get the, my ticket, my boarding pass. And then because I played, I went to London, and then London to New Delhi. I used my points because I wanted to fly, first class, because, I wanted to be a bit, comfortable. So I went to the, to the VIP lounge, and there was really some great food, rice and curry. And so, because I don't, I have to confess, I don't cook at home. So whenever I have rice and curry, I just love to have it. And so what happened was, okay, so then what happened was I was a bit frazzled because of all the previous experience with my boarding pass and everything. So I rushed to get the food. And then with the food, I turned around, and then I tripped on I sort of twisted, I think, my left, no, I think I tripped on my left foot and twisted my right or something, and I just crashed to the ground. And then I broke my, I had terrible pain. I didn't know what it was, but I was able to, they put some, bandage and so on. And so they got some neosporin or whatever like that to numb the area. And then I was fine. I was walking. And then when I landed in London, it was just very painful. And so I was supposed to go the next day and spend a night and then go to Rome to give this keynote address. And then what happened was I just, was getting more and more painful. So I went home, flew to Dallas from London, and then went straight to the emergency, and they did an X-ray and said I had a fibula fracture. Okay, so for the next 4 to 6 weeks, fortunately I didn't have to have a cast, just a what's that? What do they call it? The brace, and then I had to have a crutch, just one crutch. Anyway, that was, just wanted to have it in record of that particular incident. So I said, I promised them, I'm so sorry. I said, I can't. And those days we didn't really do Zoom conferences. I could have easily have done a Zoom conference if it had been now. So they wanted, at that time, they wanted, me in person. So I said, why don't I come next year and give the keynote? So they were very kind, the conference organizers, wonderful people. And so they reserved a spot. They said, you must come. So I gave that keynote in Vienna, Austria. So sorry for that long story, but anyway, it was just something that, since it's a historical talk, I wanted to also, go down memory lane. Anyway, so this year I've been sort of talking about role of cybersecurity and AI, and part of it also I've talked about AI for cybersecurity and AI, and how do we bring social media, right? So that was IEEE Parasocial, May 2020, and some variations I gave this year. But my current focus is now on social media governance and fake news detection. So I'm going to give a high-level talk next week on this particular topic. And then I think along with some other presentations. And then what I'm going to do is, as we do more research on fake news detection, I'm going to have a much more technical talk for the next keynote sometime, during next year. So by the way, while I was working from home during COVID, I gave 17 keynote addresses and 11 panels and podcasts and this, that, and the other. And so I'm not going to do that next year. Even though we are working from home, it's quite, it was very hectic for me giving all this, doing the recordings and then posting, and then anyway, it was hectic. So next year I will probably give no more than about 4 or 5. Let's see how many invites I get. Right now I only have 2 invites for next year. Okay. So sorry, not 2. I have 3 invites for next year. So outline. The topics are introduction to social media, social networks media, example social media analytics system, very briefly, and I'm going to talk more about this in detail next week. And then data privacy, basics, and then social media privacy, some of the experiments we carried out, access control for social media, and then conclusion, directions, and references. And much of the information I'm going to present, remember, as I said, I gave these 2 talks as well as this one, these 2 in Brazil and then in Vienna, Austria, analyzing and securing social networks. So plus a lot of our other papers and the research students' thesis, we published a book, CRC Press, and that was analyzing and securing social networks. Myself, our former PhD student, myself and Dr. Khan's PhD student, is now Dr. Satya Nabrol, and Dr. Murat's and my PhD student, Dr. Raymond Heatherly. So Satyan went to work for VMware. Raymond went to work for Vanderbilt Medical School as a research scientist soon after their PhDs. Of course, my colleague, Dr. Murat Kantajulu, and then Dr. Murat and I also had another student, Vaibhav Kadilkar, and so he's Dr. Vaibhav Kadilkar, and then he went to work for a startup, which is now doing extremely well. He's a vice president, I believe, there in the DFW area, and of course, my colleague, Dr. Latifa Khan. Okay, so that book is fairly comprehensive. It talks about analyzing social media. The first part, I believe, was, analyzing, I think, securing social media, analyzing social media, and then some of the other systems that we have developed, okay? So, or maybe analysis comes before security. So with Dr. Khan, my work was an analysis, and with Dr. Murat, my work was on security and privacy. Okay, so introduction to social networks media. So again, we know, so early social network was the Enron social graph. It was oil services, energy services company. It was really well known in Houston, Texas, but there was such a scandal in starting latter part of 2001 throughout 2002, an accounting scandal, and Enron went bankrupt, I believe, and then this Arthur Andersen, right? it had two components. The consulting arm was Accenture, and the accounting firm, but the biggest firms, it was Arthur Andersen. They went under. It was just such a scandal about some bad accounting practices. And so this was a social graph based on all the emails that people have sent. And based on the emails, you analyze the emails, what can you find, right? Some of our early work, actually, I have not even mentioned that. We did some work actually 2005 to, remember this work was, I said, was done 2006 to 16. And it actually started even before that. We had another student, myself and Dr. Murat, Dr. Ryan Layfield. So he went to work for a number of companies, I think, after his PhD, Cisco, and then Microsoft. And so anyway, so he was analyzing these graphs, and we had some very interesting early results. Okay, here's another example: romantic relations at Jefferson High School. Apparently, it's actual relation. I think it's a Jefferson High School. I think it's somewhere in the DFW area. And the blue is male, of course, pink is female, and you can see all the social romantic relationships, right? And so you can see like this girl, this female, has that romantic relationships with 1, 2, 3, 4 males and 1 female, right? And then this man has a romantic relationship with 2 females. And so based on this, students' romantic relationships occurring within the 6 months. So they had interviewed and got this, and numbers under the figures count the number of times that pattern was observed, and doing some analysis. So again, it's essentially nodes and links, right? It can represent almost anything, friendships and work relationships and so on. So emergence of online social networks, right? Online social networks become increasingly popular. Of course, we all know Facebook, one of the most popular online social networks. There used to be Friendster before that. Facebook has more than 1 billion. When we prepared this chart, it was more than 1 billion. And now I'm sure it's got even many more. More than 2/3 of Facebook users are outside of college. So older people, fastest growing demographic is those 35 years and older. Okay, so properties of social networks, there is a small world phenomenon. So back in the old days, I believe it was 1933, maybe, please don't quote me on that. Milgram asked participants to pass a letter to one of their close contacts in order to get it to an assigned individual. Most of the letters got lost, about 75%, nobody even bothered. But the letters who reached their destinations have passed through only 6 people. Origins of 6 degree. Mean geodesic distance of graphs grows, L of graphs grows logarithmically or even slower with the network size. Dij is the shortest distance between node I and j. There's some formula based on this, some calculations that have been carried out. Okay. And so it just goes through 6 people. And then now, here's another example, small world. Example, 6 degrees of Kevin Bacon. So Kevin Bacon, of course, is a movie star. We can all claim that within 6 degrees, we can reach Kevin Bacon, right? So Junet Arkin has a Bacon number of 3. So he's, I think, believes somewhere in Turkey, Kataksylia, Istanbul'da, 1974, and he has friends with Bob Bolo Young. I don't know what Bloodsport, 1998, maybe it's a movie. He was in with Forrest Whitaker, and Air I Breathe with Kevin Bacon. So some association, right? So between Junet and Bolo, it's some Istanbul'da. Between Bolo and Forrest Whitaker, Bloodsport. Between Forrest Whitaker and Kevin Bacon, the Air I Breathe. And so I think, like between, say, myself and some person, let's say Vladimir Putin. Okay, I'm just throwing his name, just came to my head. Okay, so let's see the degrees of freedom. So we have our Texas State Senator, Senator John Cornyn. So I visited, because he's a Texas State Senator, so I got my books that I published. So I went to Washington and then went and met him and gave copies of my books. So, I don't think he knows me, but when I go to the airport or something, when I see him, I say, Senator Cornyn, I'm the lady who writes the book. I'm a professor at UT Dallas. Oh yeah, I remember you, he says. Okay, so assuming I know him, say. And of course, Senator Cornyn knows President Trump. And President Trump, of course, knows President Putin, right? So it's three people. And so I'm sure everyone can claim, right, between any two people, there's 6 degrees of freedom. Okay, so what are the properties of social networks? Degree distribution clustering, right? So that's one sort of clustering that we do. Degree is that in the degrees will be in degree, how many people come into you, want to be your friend, and or come to you for advice, and how many people you go. So in degrees, the links that are coming into you in your node, and then out degree, the links that go out from your node. Other important properties, you study the community structure, associativity, clustering patterns, homomorphy. Many of these properties could be used for analyzing social networks. A lot of data analytics, data mining, we can call it today, data science, machine learning, AI being used for social networks. So what we are interested in, 2 things, social media mining analytics. And that's, I'll briefly talk about it later today, only 2 or 3 charts, the work we did. But sometime next week, I'm going to go through it in more detail. Social media analytics, a system we built called Insight. So social network data is represented as a graph. Individuals are represented as nodes. Nodes may have attributes to represent some traits, personal traits. Relationships are represented as edges. Edges may have, that's a links, attributes to represent relationship types. Edges may be directed. And common social mining, network mining tasks could be node classification. You classify the nodes, good people, bad people, or something, and predicting links. So who will you go to next? Who is going to be your next friend? Okay, so that's analytics. And I'll talk about what we have done. And much of this presentation is going to be on social media security and privacy. Privacy could be violated due to social media analytics, right? We are not intending to post that we've got maybe AIDS or COVID, but maybe based on some other information we post, right? On Facebook, people can maybe deduce what we are, whether we are liberal conservative, whether we are gay straight, whether we are, whatever, things that we don't want to mention, but we might inadvertently mention that because they can deduce by analyzing all of the data we post. So data mining and privacy, it has been studied extensively. And actually, I believe that I introduced it in 1996 at the IFIP 11.3 keynote address in Como, Italy. And then again, 1998, then IBM Almaden researchers did some very interesting work on privacy preserving data mining. And so privacy, so without a doubt, privacy, and with social media, so much information out there, privacy could be violated because data mining, data science, machine learning, they give you the ability to dig into the data and extract those patterns, okay? So another point, we have to control access to the social media data. You don't want everyone to see everything that you are posting. Of course, social media systems could be attacked. There could be traditional attacks like denial of service, attacks due to social media. So once you get access to, say, social media groups, and then target the group members. Because of social media, there are these attacks. And of course, today we are posting fake news. So it's a big problem, right? We are bots. Fake news will be discussed in a future lecture as part of social media governance. So I probably will do that next week. But then I'm going to go into more details when we, since we are doing some research, and once we get more data and more results, I'll talk about it more later on. Okay, so the next topic, social media analytics example system. So it's done by the work with Satyan and Dr. Satyan, Dr. Vaibhav, Dr. Khan, and myself. Okay, so I only have 2 charts, and I'm going to just give you the gist of it. And next week, I'll talk more in detail of our insight system. So you have, you want to find the demographics of people, because not everyone is talking about locations or various other traits, and whether they like pizza, they want to be maybe more private, right? We're talking here mostly Twitter data. And so wouldn't it be nice if you know where the person is, the location? I always turn off my location. And so even when they ask, they want to know your location, I said no. But wouldn't it be nice if, because that's my privacy, like private information. But wouldn't it be nice if marketing companies have your location, right? And they can then target. What's the point in targeting a pizza, about the special pizza you have in Dallas, in a Pizza Hut in Dallas, to someone in Los Angeles, right? So always it's good to know the location or other types of demographics. So we came up with an algorithm, agglomerative clustering. So it's John Doe. We want to find this location. So we create John Doe's a vector for his friends. So very simply put, you are where your friends are, right? So you have friend one is, the chances are is in Dallas, Texas, is 0.4, Seattle is this, Richardson, Sydney, and friend two, these are the probabilities or possibilities, and friend three and friend X and so on. And then you apply our algorithm, and then it says Dallas, Seattle, Richardson, and various other things. And eventually it will say that the person, the chances are he's going to be in the Dallas DFW area. Okay, so that is the result. You can see Dallas, Texas, Richardson, and Plano, Texas, all in the DFW area. But it's very straightforward when I talk. It sounds straightforward, but it's really very deep algorithms. And based on this, we developed a system, okay? Detailed design and implementation of Insight. That's going to be given in the future. We talked about Vedanta, and then we developed Insight, and then it's patented system. And we also have done some work on technology transfer of the system. So again, right? Look, by giving out the location, we can mine. No, we haven't given out the location. We have done some data mining, extracted the location. Of course, privacy is violated, right? So we are not talking about privacy here. So I just want to talk about what we are trying to do. Right, developed 3 graph based location mining algorithms. I'm only talking about location, and then I'll talk about this in a minute. Map location mining problem to K nearest neighbor. That's one. Semi-supervised and graph partitioning problem, 3 algorithms. Outperform content-based approaches in time and accuracy, right? The speed and accuracy. Relationship behind geospatial proximity and friendships, that we take that into consideration. And so people moving, your friend would have moved just because he's in Dallas, Texas today, doesn't mean he's going to be in Dallas, Texas, yesterday, doesn't mean he's in Dallas, Texas today. So relationship between geospatial proximity, effect of geographical mobility on current location of users, and predicts demographics, preferences, lots of stuff. So this is our architecture of Insight. We have developed Insight for security. Is a person a potential bad person, a terrorist, or a criminal that law enforcement might want? Or is a person, what are the preferences of a person? So we did Insight security, Insight marketing, and then of course, Insight healthcare, which we haven't done, which will be tremendously useful for COVID-19. And so we have marketing, we have an Insight as an information engine. So, okay, the output is marketing, Insight marketing offers. So information engine does sentiment analysis, entity extraction, tweets. So we get, okay, you start here, all the tweets, social media, databases, and then we try to integrate all of the information, right? Insight time streamer, relevant streaming of tweets, Insight profile for client, and then we have also built a dashboard, which was security for marketing and other applications, and you do a lot of integration here. And then from this, all the information that you gather, you log in, and then you have the real-time and person of interest analysis. Of course, this module has got access to all of this other information, okay? So, but here you integrate the information, and then there are different moving parts here, right? One part goes to the dashboard. The other part is going to the information engine to do a lot of analytics for, sentiment analysis and so on. And then there's some data storage, and that part goes in here to the dashboard, and then it goes into Insight real-time person of interest analytics. So there are 2 things. Is the person of interest to us? And another output we get is what sort of marketing offers should we send? Or maybe other things that we send, other aspects that's related to this person. Okay, so we have an information integration, and then we have information analytics, and then we build profiles and we go into the dashboard, and from the dashboard, user can log in and then get information, so you can either send marketing offers, or once you do the analytics, go into the storage, come to the dashboard, and then say is the person of interest or not. Okay, so it's a very nice system, and it's patented. Okay, so that finishes analytics, but the main point here, because of the capability and we have divulged the location, of course, our privacy has been violated. And we divulge the location by not the person mentioning the location, but all of the other information about that person using the algorithm we mentioned in the previous chart. Okay, agglomerative clustering. Now, the next topic is some data privacy basics. So, how to share data without violating privacy. Meaning of privacy, it's identity disclosure and disclosing sensitive attributes. But how do you measure privacy? So there are various techniques for structured data, includes K-anonymity. This is by Professor Latanya Sweeney from Harvard. L-diversity, I believe it's from L-diversity. Johannes Gerke, he was a Cornell, he's a Microsoft researcher, I believe. Dr. Johannes, and differential privacy is, this professor, very well-known professor, she was at Microsoft, Dr. Cynthia Dork. She was at Microsoft Research, she's now at Harvard. And secure multi-party computation is my colleague, Dr. Murat Kantarjulu, and Dr. Chris Clifton. So publishing private data while at the same time protecting individual privacy. So the whole idea is to protect individual privacy, but publish data. So people who live in, say, Dallas-Fort Worth have got a higher incidence of COVID or cancer or primary liver cancer. So those results for epidemiological studies are very useful, but you don't want to say John Smith has cancer, right? Challenges. How to quantify privacy protection, how to maximize the usefulness of published data, how to minimize the risk of disclosure. That's a challenge. Another way of looking at privacy, which is what I did a lot of work on, inference problem. So in a way, my sort of claim to fame in the early days was on my work on inference. And that's sort of a little bit different. Privacy, we want to protect our individual privacy, but we want to also give out information about what? About the studies, right? Based on population, right? So, I mean, so this particular group has the chances of having cancer is higher, right? That information, you need to give out because that's important for epidemiological studies. But the inference problem is that you have individual pieces of information is unclassified, but you put collections, and the collections could be highly private and highly sensitive. So it's a little bit, sort of the opposite, right? So that's data privacy basics. Now, sanitization and anonymization. Automated de-identification of private data with certain privacy guarantees, opposed to formal determination-based decisions. That's a requirement of HIPAA. Two major research directions as perturbation and randomization. So perturbation / randomization, random noise addition, and anonymization, as Professor Sweeney has said, K-anonymization, right? So, and I think we are going to talk about that. Removing unique identifiers is not sufficient, right? You can remove unique identifiers, but then you can put records together, right? Just because, you can remove some identifier that is identifying the record in one record, another record, same thing. You can put the two records together and you can get all the private information. Quasi-identifiers, maximal set of attributes that could help identify individuals, right? So one attribute may not be enough. We may need 3 or 4. Assume to be publicly available voter registration list as a process. Remove all unique identifiers. Identify the quasi identifiers, model adversaries' background knowledge. Is a very challenging problem, and enforce some privacy definitions like K-anonymity. Okay, so re-identifying anonymous data, Latanya, Professor Sweeney in 2001, she looked at 37 states mandate collection of information. She purchased the voter registration list for Cambridge, Massachusetts, 54,805 people. You can see zip code, birth date, and gender. Here the medical data voter list. And you can see from medical data, ethnicity, visit date, diagnosis procedure, medication, total change. On the other side, voter list, name, address, date, registered party affiliation, date last voted. 69% unique or postal code and birth date were unique, right? 87% US-wide with all three. And solution, she says, K anonymity. Any combination of values appearing at least K times. Develop systems that guarantee K anonymity, okay? So this particular system, right, has K anonymity, so some level of privacy. Minimize distortion of results. Okay, so what is K anonymity? Each release record should be indistinguishable from at least K minus one other. So every time you release something, it should be indistinguishable from at least K minus one, right? On its quasi identifying attributes. So that means you're one of the gang. So you don't know which person. That's to create as much doubt as possible. So you have two anonymity. That means every record should be indistinguishable from at least one other, right? So of course, 8 anonymity might be even better. Every record should be indistinguishable from at least 7 others. So then you create more doubt. Alternatively, cardinality of every query result on release data should be at least K. K anonymity is the first one of many privacy definitions. There was L diversity, Professor Johannes Gerke, and then T closeness, I think it was Professor Lingwei Li. M variance, delta presence, I don't know too much about those. I only know about K anonymity, L diversity, T closeness, and differential privacy. Complementary release attack, right? Different releases can be linked together to comprise K anonymity. Solution, consider all of the release tables before releasing the new one and try to avoid linking. Because remember, linking different records, privacy could be violated. Other data holders may release some data that can be used in this kind of attack. Generally, this kind of attack is hard to be prohibited completely. Okay, so now we go to privacy preserving distributed data mining. This is really one of the major breakthroughs made by my colleague, Professor Murat Kantarjalu, on distributed data mining, together with his advisor, Dr. Chris Clifton, who I work with. He actually worked in my department. I was a department head back at MITRE. So it's sort of a small world. And then Murat joined us. Goal of data mining is summary results, association rules, classifiers, clusters. The results alone need not violate privacy, right? Contain no individually identifiable attributes, reflects overall results, not individual organizations. Data need for data mining may be distributed among parties. So you want to distribute the data. No one person has all the data, credit card fraud data, inability to share data due to privacy reasons, HIPAA regulations. Even partial results may need to be kept private, okay? So the problem is computing the results without access to the data. So essentially, I think what I want to do here is, sorry about that, I shouldn't be doing this, but right, I just want to move it down so we see that, okay. Okay, so privacy preserving distributed data mining. Now, secure multi-party computation, I'm going to explain to you, go through this and explain to you sort of in kind of layman's terms. The goal is computing a function, okay, without revealing these are the individual data. You know, someone has cancer, someone has diabetes, someone has COVID, but the function will say per people who live in DFW, higher incidence of primary liver cancer, right? Semi-honest model, we are saying all the parties must follow the protocol. Malicious model, parties may or may not follow protocol. It's more confusing, right? We cannot do better than the existence of the third trusted party solution. Generic SMC is too inefficient for privacy preserving distributed data mining, enhancements being explored. So the whole idea, each one of us in this group of people in a room, they have a secret. They are not going to divulge the secret. They're going to encrypt. How do you compute it? They're not going to tell the secret. How do you know that, you know, majority of the people living in, DFW is having primary liver cancer? So everybody has a secret. You encrypt the secret, and then you put it in a basket or something, and then you compute this function with the encrypted data. You work with the encrypted data, the data mining, distributed data mining, then it's going to decrypt the data, the final result, and you broadcast it without saying John has cancer, lung cancer, Jane has liver cancer. Without that, people who live in DFW, higher incidence of liver cancer. It's not, by the way, I'm just making it up, okay? Fine. So that sort of gives you data privacy basics. What have we done with data privacy? Okay, preventing private information, inference attacks on social networks. So it's a lot of work, and I'm just going to summarize. It's a PhD thesis by Raymond Heatherly. Dr. Heatherly is, after his PhD, joined Vanderbilt Medical School as a research scientist. Of course, my colleague Murat Kantarjalu and myself. And then we had a master's student, Jack Lindemood, and he finished his master's and he went to work for Facebook. He was one of the early Facebook employees. I'm sure he must be a multimillionaire by now, but I don't know exactly, because he's gone to work for some other company right now after working for probably many, many years for Facebook. And their first job after graduation. Okay, so it's a joint research. So machine learning, data mining, and privacy. I just want to give some more basics. Machine learning techniques can analyze the data and extract new patterns and trends, disease information. These patterns could be highly sensitive and or private. We carried out some experiments on Facebook applying machine learning. So we have a graph model. So later I give all the references, okay? Lindemood and Heatherly. Okay, so graph represented by a set of homogeneous vertices and a set of homogeneous edges, right? Nodes and links. Each node has a set of details, one of which is considered private. These were the assumptions. So one link is private, right? It could be whether I'm gay or straight, or it could be whether I'm a liberal or conservative. So we don't want to divulge what we want to find out about a person. And so the actual algorithms, machine learning, we have naive Bayesian classification based only on specified attributes in the node. And this is the formula, the equations. And our paper describes everything, multiple papers, I'll talk about it later. Naive Bayesian with links, rather than calculate the probability of person nx to ny, we calculate the probability of a link from nx to a person with ny's traits. And this is the equation for naive Bayesian with links. Link weights, links also have associated weights, like how strong is the friendship, right? Represents how close a friendship is, suspected to be used using the formula. So WAB is, okay, again, our paper talks about what, the D's and the T's stand for. So, okay, so it's not so straightforward, right? Collective inference, that's a machine learning inference technique, collection of techniques that use node attributes and the link structure to refine classifications, using local classifiers to establish a set of priors or priorities for each node, use traditional relational classifiers as the iterative steps. So collective inference, jointly you do inference, right? Different types of inference methods that you can combine. That's the machine learning. Relational classifiers, class, distribution, relational neighbor, right? So you want to, the relational data that you can do classification, weighted vote, relational neighbor, another type of algorithm, network only based classifier, and network only link based classification. These are all algorithms in the literature. Okay, so what did we want to do? We wanted to figure out, is a person liberal or conservative? And so we looked at 167,000 profiles from Facebook online, social network, restricted to public profiles in the Dallas-Fort Worth area, over 3 million links, okay? So the general data properties, diameter of the largest component that's sort of connected, right? It's going 16. Number of nodes, 167,000 plus. Number of friendship links, 3 million plus. Number of listed traits. People are saying that they are, they like to go to maybe church, or they like to go to the movies, or they like James Bond's films. Listed traits, 4 million plus. Number of unique traits, right? 110,000 plus. Number of components, because one component is all connected like that. Remember the friendship in Jefferson High School, there were different components. So there are 18 components. And in ours, so we wanted to figure out, is a person conservative or liberal? So that DFW, where although it's considered to be sort of more liberal among other states in Texas, like Austin, Dallas and Houston, and San Antonio, the big cities, But again, if you look at the entire metroplex, right, the probability of liberal is 0.45, probability of conservative is 0.55. So we did work, is a person liberal or conservative? And at that time, MIT was also doing the work. So we got a lot of coverage for this, ABC News, Boston Globe. MIT was, why? Because of course, everybody is interested to find out liberal conservative, but MIT did something even more interesting. They did to the general public, is a person gay or straight, right? So just by posting to see what he's posting, right? And so it was very interesting in the sense, but they are not posting, if they have said that they are gay or straight explicitly, or for us liberal or conservative, we've removed those traits, okay? So, and then were they able to machine learning algorithms predict the gender preferences or whether you are liberal conservative, right? So inference methods, we details only use naive Bayesian classifier to predict the attribute. Links only, we use only link structure to predict the attribute. Average classifiers based on the average of the probabilities computed by details and links. Okay, these are the inference methods. And again, I'm going to give you the reference to these papers. Okay, that's inference. Then predicting private details, attempt to predict the value of the political affiliation, right? Attribute. So there's one attribute, political affiliation. We have removed it. We have to predict it. And MIT's work, the gender preference, they have removed it and the algorithms have to predict it. 3 inference methods used as a local classifier. Relaxation labeling used as a collective inference method. Removing details ensures that no false information is added to the network. All details in the release graph were entered by the user. Details that have the highest global probability of indicating political affiliation removed from network. So removing links ensures that the links structure of the release graph is a subset of the original graph, right? So we remove it, but don't add stuff. It's a subset. Removes links from each node that are the most like the current node. So in the DFW area, we found most liberal traits legalizing same-sex marriage, right? And the conservative person don't say marriage, will not say, will of course say marriage is between one man and one woman. Whereas if you are more liberal, you will say marriage could be between 2 men, or marriage could be between 2 women. So every time I find a cute boy, is conservative, a little part of me dies. Equal rights for gays. The Democratic Party, not a Bush fan. People who cannot understand people who it was kind of in the late 2000s, right? So it was more about George W. Bush. Government, religion, disaster. These were all weighted liberal. So these were liberal traits we wanted to remove, because if one person says, right, government, religion is a disaster, the chances of him being conservative is somewhat slim, I would say. Most conservative traits, George W. Bush is my homeboy, college Republicans, Texas conservatives, bears for Bush, Kerry's a fairy, Aggie Republicans, keep Facebook clean, I voted for Bush, protect marriage, one man, one woman. Okay. And then most liberal traits per trait name, activities like Amnesty International, employer hot topic, favorite TV shows, queer as folk, grad school computer science, hometown Mumbai, relationship status in an open relationship, religious views agnostic, looking for whatever I can find. Okay, so experiments we conducted on 35,000 nodes, which recorded political affiliation, removing lots of testing, 0 details and 0 links, 10 links and 0 links, 0 details and 10 links, and 10 details and 10 links. Vary training size from, again, training testing, 10% of available nodes to 90%. And remember, we had local classifier and collective inferences. So local classifier, right, in the local areas, right, in the distributed data, local data. We looked at classifier, accuracy, percentage of data in the test set. So here we found 0 details, 0 links removed. And then we said average, details only, links only, okay? And similar, the same thing, details only. Remember, we said details only, links only previously in one of the charts. And percentage of data in test, so it's 0 details, and we have removed 10 links. Here we have not removed anything. And then 10 details, 0 links, and we get the graphs, and 10 details, 10 links. Okay, so we have details removed, and then 10 details, 10 links. And that's for location classifier. Collective inference is, all these location classifiers, you combine it together. And then you have zero details, zero links removed. You have local only and various other Bayesian and various other inference techniques. And then you combine everything. And the same thing here, 10 details, 0 links, and 0 details, 10 links. And so these are different classification methods. Okay, 10 details, 10 links. It's all in our papers. Okay, what are the lessons learned? With each machine learning technique, it was possible to infer private details. Some machine learning techniques extracted more private information. Solution, privacy enhanced machine learning data mining. For social media, do we want that? Idea is to perturb some data to introduce random values, but the end results associations remain the same. So these are the lessons learned. So the next question we said was, now that we know that privacy is indeed violated, we have conducted experiments. And so the question is, do we want to do work on privacy preserving social media? So we had discussions, and then we said, the problem is Facebook is it going to adopt our solutions? Because it's one thing doing the research, but we also wanted to have an impact, right? And so we talked to some folks, and then, there didn't seem to be a whole lot of interest, right? There were some others who have done some work on that. And when I talk about inference problem, and I'm going to talk about it later, I'll also bring that up, because can you combine all the details and infer something that is highly sensitive, highly private, or top secret, right? That's a different problem. So privacy is, again, individual values are kept to yourself, and the value that you get as a result of machine learning, right, data mining, right, those are something that you may need for the public good, such as figuring out where COVID is more prevalent or where cancer is more prevalent. Okay, so that these were the lessons learned. Now we go to another topic, right? So we've talked about the Insight system, right? Analytic system. I'll elaborate on that another lecture. And then we talked about privacy for social media. We proved that privacy could be violated through experiments. Access control. How do you control access to the data? And this is with our colleagues, Professor Barbara Carminati, Professor Elena Ferrari. They are both in University of Insubria, top-notch researchers. Raymond Heatherly, of course, Dr. Raymond Heatherly was our PhD student. And as I mentioned in my earlier section, after he finished his PhD, he joined Vanderbilt Medical School as a research scientist, and then my colleague Murat and myself. Okay, online social network access control. Current access control systems for online social networks, either too restrictive or too loose. Selected friends, Bebo, Facebook, multiply, neighbors, that is set the users of having musical preferences and tastes similar to mine. Friend of friends, Facebook friends to Orkut, contact of my friends, contacts, second degree contacts, third and fourth, and so on, Zing. Okay, so it's either too restrictive or too loose. So what is the right type of access control? Many different online social networks with different terminology, Facebook versus LinkedIn. We need to have flexible models that can represent users' profiles, relationship among users. Bob is Alice's close friend, resources, online photo albums, relationship among users and resources. Bob is the owner of the photo album, and Alice is tagged in this photo. So post on message on someone else's wall, right? So, okay, so these are some of the requirements we felt was important. And our solution is to use semantic web technologies. Example, OWL, web ontology language, to represent social network knowledge base. We use semantic web rule language to represent that SWIRL. These are Sir Tim Berners-Lee's technologies to represent various security, admin, and filter policies. And we published this paper actually in 2009 at the ACM SACMAT conference. It's a top tier conference, and later I'll talk about it. And then this paper had a lot of citations, and 10 years later in 2019, they give a test of time award. So in 2019, we got the test of time award, that it has stood the test of time. and as the most influential paper the past 10 years. And I was quite fortunate because and so this work was with the access control work with Dr. Murat, Dr. Raymond, and Dr. Barbara and Dr. Elena. And then the previous year, I did some work with researchers at University of Maryland, Baltimore County, University of Texas, San Antonio, and MIT. And that was on developing, combining OWL with the role-based access control. We called it ROWLback. And so that was also published in ACM SACMED 2018, which got a 10-year test of time, 2008, which got a 10-year test of time in 2018. So I was very fortunate to get 2 test of time awards back to back. Anyway, coming back to this, our solution based on semantic web, right? So modeling user profiles and resources. So we use the semantic web community social network called FOF, friend of a friend. Could be extended to capture user profiles, right? So friend of a friend, this is again represented in RDF, and I'm not going into the details. It also catches all the user profiles. So we have John is the friend of Mary, is the friend of this, and John's properties, and we can have a sort of full-fledged social network connections. Relationship among resources could be captured by using OWL, web ontology language. Photo album, for OWL, you have to use RDFS, subclass of resources. A particular class is a subclass, and photo album consists of photos. Okay, so we model the relationship among users. We model relationships among users by defining an array relationship. Christine is a person, has friendship relation 1. What is friendship relation 1? A friendship relation, friendship trust is high, and the friendship value of the friendship is Mike. Our reasoners cannot be used to infer some relationships such as Christine is a 3rd-degree friend of John, right? Such computations needs to be done separately and represented by a new class. So these are some of the ways that you can represent relationships in OWL. So what do we do? Specifying policies. What are the policies? Using online social network knowledge base. So you can see Bob is a friend of David, David is a friend of Bob, Alice is a friend of Bob, Bob is a close friend of close friends. They are close friends. And distance friend of Charlie, Charlie is a friend of Alice, right? And Alice owns photos, and Charlie, and this photos contains photo 001, and it's a photo of Charlie. Most of the online social network information could be captured using OWL to represent rich set of concepts. This makes it possible to specify very flexible access control policies. Okay, photos could be accessed by friends only. Automatically implies close friend can access the photos too. Policies could be defined based on user resource relationships easily. Okay, what are policies? Policies are these access control policies, right? John can have access to Alice's photos. Alice or only your friend can have access to your photos. These are the policies. So what are the policies? We have access control policies, right? Controlling access, filtering policies could be specified by user, could be specified by authorized user, what you want to filter. Admin policies, security admin policies specifies who is authorized to specify filtering and access control policies. So if U1 is a parent of U2 and U2 is a child, then U1 can specify filtering policies because you want to filter what your child sees. And so security policy specification using semantic web, we use SWIRL, semantic web rules language, for specifying access control, filtering, and authorization policies. So policies in SWIRL, the social network represented in OWL, all the relationships. SWIRL is also based on OWL. All rules are expressed in terms of OWL concepts, classes, properties, individuals, literals. Using SWIRL, subject, object, and actions are specified. Rules can have different authorization that states the subject's rights on target object. So photo of a target object and photo of grantor, target object implies admin. Okay, so if the photo is of a target object, okay, photo of the grantor and the target object, right? So, and the admin read, the grantor will give admin read to the target object. If you are the, if it's a photo about yourself, surely you can look at a photo. That's what it's saying. Now, knowledge base for authorization and prohibitions. Authorizations, prohibitions need to be specified. So do you want to explicitly specify prohibitions, right? Different object property for each actions supported by OSN. Authorizations, prohibitions could automatically propagate based on action hierarchies. Assume post is a subproperty of write. If a user is given a post permission, then user will have write permission as well, right? These are some of the subproperties. Post is a subproperty of write. If you can post, right, it's a subproperty of write. So if a user is given post, then he should be able to write, he or she. Admin prohibitions need to be specified slightly differently. Supervisor, target object privilege. Okay, so security rules example, a swirl rule specifications does depend on the authorization and the online social network knowledge bases. It is not possible to specify generic rules. Okay, so essentially, if the video of a target object, right? So I'm making this video. Parent of Bob controls. Okay, so if the video is a video of a target object, then parent of Bob controls what Bob sees, okay, of this video. So if Bob is the owner of the target object and the photo is the target object, right? So Bob could be owner of his photo or Alice's photo. And Bob is a friend of the target object. Then Bob can read, okay, and then the target, Bob is a friend of target subject. So Bob is the owner of the target object and the photo of the target object. And Bob is a friend of target subject. Bob is a friend of John. Then since Bob is the owner, Bob's friends can read anything that he owns, the target object. Here, the target object is not owned by Bob, but instead the target object is that of Alice, a photo of Alice. And so all of Alice's friends can read her photos. And this is a more generic version of the previous policies. Okay, so your parent controls what you see, right? A video of a target object, and Bob's parent controls, right? And so you know, parent controls essentially what you read, right? And then the second one says that if you own something, all your friends can read that. Or if it's a photo of yourself, then all your friends can, you know, look at your photo. So a security rule enforcement. So what is the research, you can say? You're saying, okay, you're taking stuff from here, semantic rules and various other things, and then putting it all together. But the research is we want efficient execution, right? Friends cannot wait for 10 minutes to get access instantly. So admin request for access control, query rewriting or policy rewriting for efficient execution. Example, assume Bob submits the following, right? Again, I'm sorry, I will have to put this down. I should have, okay. What is going on here? I'm just a second. Just bear with me a second. What am I doing here? Example, Bob. Okay, so rewritten version. So I think I want to just, I'm so sorry about that. Should have checked this earlier. But again, these are sort of kind of informal presentations. Do it as you go. This is a more organized. Okay, so what are we doing here? Remember, the research is rewriting. A reference monitor evaluates a reference. So actually it's right here. A reference monitor, that is that part of the system that is security critical. It evaluates the request. Admin request for access control could be evaluated by rule rewriting. We rewrite all the rules or policies. Example, Bob submits the following request, right? Bob's target object, Bob is the owner, and all the objects that he owns, his friends can read. And we are rewriting, but this is very inefficient to execute. So we rewrite this, again, same meaning, a new swirl rule, right? So this is more efficient to execute. So that is part of the sort of the fundamental research, right? Other than, you know, taking various systems and putting it together. So that's security rule enforcement. So admin requests for prohibitions. So this is for access, right? Admin requests for access. For prohibitions could be rewritten. So Bob issues the following prohibition. The video and the parent of Bob can, okay, so parent of someone can control what he sees. And so we rewrite it this way, and it's much more efficient to execute. Access control request needs to consider both filter and access control policies. Then we develop the system. our framework. So we used semantic web reasoning engine, and I believe we used, various systems out there like Pellet, I believe, University of Maryland, College Park, they had an open source, and the policies. This is a social network knowledge base, the social network. These were all the policies. These are the applications, access request, access decisions. Reference monitor is that part of the system that is security critical. It's moderating or is mediating all the access. So the data and to the policies and making sure everything is tamper proof, everything is carried out correctly. And this is the reasoning engine. It's going to reason. If I give out this, is he going to infer something, or is A implies B, B implies C, and all those kinds of stuff that the semantic web reasoning engine is going to, like a friend of a friend of a friend of a friend can read. So you got to reason, right? Are you a friend of a friend of a friend of a friend? So those are the things that the semantic web reasoning engine is doing. So this is a very nice prototype, and we published, as I said, ACM SACMAT. This is something, okay, so that finishes access control. I just threw in this bit, which is sort of an offshoot sort of chart from yesterday's presentation. Yesterday, I talked about assured information sharing in the cloud. Okay, so just a second, I want to just make sure, check the time. Oh, that's okay. So yesterday I talked about assured information sharing in the cloud. Right? I talked about policy-based information sharing, and I talked about our semantic web-based policy manager, and then our Sparkle Query Optimizer implemented on top of Jenna. So we had, everything is in our, I discussed two systems we developed. This is a second system. So we have policy management, like policy translation and transformation, then RDF data preprocessor, then we have the MapReduce framework for executing XACML, the policies were specified not in XACML, policies were in RDF. The first prototype was in XACML. We used Hadoop MapReduce, right? We refer to the video presentation on cloud-centric assured information sharing for the background that was presented yesterday, in my yesterday's presentation. So, and we demonstrated between agencies. So it's a joint project between UT Dallas, King's College, University of London, University of Insubria in Italy. And we demonstrated how information could be shared, right, securely according to the policies. So policies were sort of, as I mentioned, toy policies, right? I share something with you. So John tells Mary, I will share this information with you, provided you don't tell Jane. These are toy children's policies. So we of course work with top policy experts too, focus on real world policies. So then we did some work, some research on how can we apply this kind of system for social networks, people belonging to different social networks, having to share information for, for emergency preparedness, for military reconstruction and stabilization after a war, to do good, for public good, right? So for epidemiology, for COVID-19 spread, so different agencies, they belong to different social networks. Across social networks, how do you share? But then we didn't pursue with this research, mainly because we didn't, the project finished, and this was, in a way, we felt that, is there some deep research in there? Because, we have to do research because we are professors, right? So, and is it sufficient for a PhD thesis? But in any case, we presented it at the Parasocial workshop, and that was back in 2016. Okay, secure social networking in the cloud. So policy-based information sharing. I just threw this, just to add this, maybe some more work that could be done. Okay, so now I come to the end of the presentation, conclusions, directions, and references. So first, conclusions and directions. Social media analytics may lead to data privacy violations. That was one conclusion. From our insight system, we were able to predict locations. That itself is a privacy violation. And then various attacks exist to identify nodes in anonymized data and infer private details, right? We showed that. And so through our experiments, right? Are you liberal conservative? And MIT did, are you gay or straight? Recent attempts to increase social network access control in order to limit some of the attacks. And so we said, we came up with the access control model, balancing privacy, security, and usability, right? Privacy, security, and usability on online social networks will be an important challenge. I also want to talk about, when we talk about privacy, security, usability, we also may want to add utility, because you can mask the data, but what is the value of the data? And then masking the data, what is the cost? But again, what our focus for social media is the usability, right? Because people are using this social media, right? You don't want it to make it very restrictive. Directions, of course, scalability. As I said, well over 1 billion people now on Facebook, and more people joining. Implement secure social media systems in the cloud and various other high performance computing systems to test the scalability. Of course, usability, you can create techniques to automate various learning rules and create some simple user interfaces so that users can easily specify these rules. So one of the challenges I'm finding, especially using these various social media systems, I think they are making it quite complex, because it was so straightforward those days, right, with little few features, but they're adding more and more features, and in a way they are not paying as much attention to usability of these systems, right? So sometimes they're introducing these walls, and they're continuing to tell their stories, and it's just very, they're making it very complicated, and sometimes you don't know which one. So I'm still sticking to sort of a simple, in my mind I've got a model and I'm following that model, but I may not take full advantage of what's out there. And of course, today, fake news detection will be an important direction for the future, together with social media governance, and our work will be discussed in a future presentation, a high-level work, but I'm going to go into some more details, as we do research sometime later on. Next week, I'll talk about my high-level work and then more details later. Okay, references, two sets of references, one focusing mainly on social media security and privacy. So one was on World Wide Web, 2009, ISI 2009. So joint work, you can see Barbara, Elena, Raymond, Murat, myself, and Jack Lindemood. So these are all the sort of authors. This is sort of a fairly significant paper, IEEE transactions. This was mainly Raymond's PhD thesis. Some of that work I haven't talked about. So these are all of the work, this is more than sufficient to some of the social media security and privacy I discussed. And then for our insight work, social media analytics, again, the folks here are Satya Nabrol, Vaibhav Kadilka, but I also don't want to forget some others who have worked, Gunasekar Rajasekar, and then we have Siddharth Nagarajan, Nathan McDaniel, and Gautam Ganesh. They all contributed to the insight system, especially insight marketing. So they came to the team, they were all master's students. Satyan and Vaibhav were PhD. Nathan did the master's, and so did Gunasekara and Nagarajan and Gautam Ganesh. So, and then of course we had Satyan and Latifa and maybe myself, we worked a lot on the system tweeted algorithms, we call it, insight system. We tweeted and tweakalization and tweak algorithms. And then we combined it with some geospatial data. Jeffrey Patika's research was on geospatial data and geospatial data analytics, sort of interesting work. And Satya Nabrol, Latifa and myself and Vaibhav and Tyrone Cadenhead, right? He has contributed too. Design implementation of SNODSOC, right? Novel class detection for social network analysis. We presented at ISI 2012. Stream-based novel class detection and for social media. So we had stream-based novel class detection for malware. I briefly discussed it on Sunday, December 27th. Some of our novel techniques, ensemble of classification techniques, how we apply it to social media. ISI is intelligence and security informatics. And the last was a tweakalization, and that was presented at CollaborateCom 2012. And as I said, I'll talk about insight in a future presentation. But one of the main things is our book, which I have not mentioned because it combines security and analytics all together with CRC Press. I mentioned it in my earlier charts, Analyzing and Securing Social Media. Okay, so that ends the talk, and I'm going to stop sharing. Okay, so some of the key points. Without a doubt, right, we cannot go back to pre-social media days. The last 20 years, things have really evolved. And social media, without a doubt, is very good for us in the sense that, especially these days with COVID, right? We are home, and I find so many people, being on social media, and they are, connecting with friends. It's not like the human sort of contact and connection, of course, but it doesn't replace that. But it helps us a lot, and so that's great. That's a good part. The not so good part is, people bragging all the time on social media, all the wonderful places they have visited. And then it's so sad, right? Some others will sort of social media envy. We know it's a big problem, right? So psychologists and sociologists are studying social media envy. But social media, another good thing is that it helps with the emergency response, COVID-19 pandemic, catching terrorists and bad folks, and also for law enforcement, and you can spread the message so quickly in social media, which is so good. It's another good part. Another bad part is that people can post all kinds of bad stuff about other people, right? And so that's really very negative. So that's not good. Another very bad part is all the fake news that's out there, right? How do you know whether something is false and something is not false? And fake news, and how can you trace it back to the original person, right? So the thing is, who spread it? It's a person, or is it a hacker who has gotten bots all over to carry out the bad work for him or her? So, and that, causes a lot of danger. And also cyberbullying on social media. We have heard of students, boys and girls, committing suicides, young adults committing suicide, and children, teenagers committing suicide. That is very, very tragic. Each time I, hear of something, I'm really sort of heartbroken, right? Two things really get me very, very, very unhappy. One is, of course, social media bullying, and when children are committing suicide. And another thing is when I watch television, when they show St. Jude, cancer, children with cancer, it is just so heartbreaking. It's nothing to do with social media, but something that that sort of brings tears to my eyes. There's both these things. Of course, there are other things that make me sad too, but especially these two. So without a doubt, we have to use social media for social good, right? We have to focus on that. And in order to do that, we cannot work by ourselves. It's not just a computer scientist. Computer scientists have to work with policy experts. They have to work with sociologists. They have to work with psychologists, right? There are some experiments psychologists have done about drug addiction and using social media. How can you prevent drug addiction? So again, try to do good things, right? So computer scientists and mathematicians, we need them to compute all the, it's based on graphs, nodes and links, right? Not scalability, the mathematical solutions, and statisticians. So you need, computer scientists, of course, and mathematicians and statisticians and psychologists and sociologists and so many people, right? To have to work together in order to use social media for the public good, right? And with that comes, analytics to carry out in an ethical way. And the other thing is to not just analytics, also security and privacy. You also want to ensure the accuracy of the data that has some connections with fake news, right? We don't want fake news. Another thing I wanted to mention, remember I said that we didn't want to do privacy preserving social media. Another thing with inference is that, you post something, right? The social media system can look at all the information that you have posted, and collections of data together that you post could be highly sensitive. That could be highly private as well. So when I first started working on social media and privacy and inference, right, I said, wouldn't it be great if once you post something, without it getting posted instantaneously, but very rapidly. Facebook can do a rapid test to look at all of the stuff that we have already posted together with the new stuff we are posting. Oh, they'll say, if you post this, then you are telling, you are giving out this highly sensitive information about yourself, that you are conservative or liberal or gay or straight, or you've got diabetes, or you've got, some things, right? Or COVID or whatever. So do you really want to do that? It'll be wonderful if Facebook can do that. But, right, I don't know whether Facebook is going to do it, because for two reasons. The performance, right? People are very impatient these days, right? They want instantaneous results with technology. And the second thing is it really Facebook's responsibility, right, to sort of censor what people are posting, right? Because, it's sort of, that's again, then, if Facebook and Twitter cannot control what everybody is posting about everything else, right? So that's where we are having all these debates now, right? The lawyers, right? There's a place for lawyers too here, not just those working regulations or policy experts and so on. And there's also a place for lawyers here. So we all have to work together. And so what I want to do, sort of my closing message, without a doubt, social media is very good, but we have to do ethical analytics, right? Social media systems could be attacked, right? That's another thing. I didn't talk too much about that, malware attacks on social media. Of course, I talked about access control and the privacy violations. And so, right, social media cannot be for public good in the midst of privacy violations and security attacks. In fact, I gave a banquet address at the ACM CODA-SPI conference on data and application security and privacy. It's a top conference for the field, and I work in that field. So that's our flagship conference. And so what I'm saying here is that, so the banquet, in the banquet address, the topic was, can AI, artificial intelligence, be for good, right, in the midst of privacy violations with machine learning, as we said, right? You can apply machine learning and privacy could be violated. And in the midst of privacy violations and security attacks, right? There's malware everywhere. Attackers can attack your AI techniques, could be attacked, right, themselves. And that's sort of has been my theme throughout the keynote addresses I've given over the last 9 months. Okay, so that is adversarial machine learning, some of the work that we are doing. If you look at some of my previous talks over the last 9 months. And so again, can AI be for social good in the midst of cybersecurity violations, security attacks, and privacy violations? And I looked at protecting children. That was, it was the main focus was violence against children. Similarly, I'm saying here, can social media be for good in the midst of privacy violations and cyber attacks and access control problems, as well as cyberbullying and so many other things, right? With AI, we are not talking about cyberbullying with AI, but when we talk about social media, you have got all the bad things being posted and fake news and all those things. AI could be a tool to detect these fake news. Okay, so that's something that we have to keep in mind. We want to use social media for social good as well as for good of everything, for disease detection, for counterterrorism, for law enforcement. We all want to use social media in an ethical manner. So I want to leave you with this, and stay tuned for my lecture tomorrow. And I believe that's going to be on a short lecture presentation on big data, security, and privacy. Okay, so, and again, thank you very much for listening to the presentation. And so what I'm going to do now is end my presentation. And again, thank you.